All right, everyone, Mrs. Martin here again with notes for today on solving systems using substitution. We left off last time graphing these systems of equations, linear equations to be precise right now for Algebra 1. And this is what we ended up with. We graphed these two lines, we graphed them by hand last time. Today I'm using Desmos. And we determined that their solution was the point where those two lines cross. And in this example, that point is 1, 2. And so again, this means that if I take 1, 2, and I plug them into both of those equations, and we'll check that in a minute. When I plug those in, then it is going to be true for both. So those results will be true on both linear equations. But it's not always going to be effective graphing these things. We don't always have graph paper. We won't always have Desmos. And we won't always have nice numbers either. In this case, I did pick a system that gave us some nice numbers. So we need another method besides just graphing them and looking for their intersection. And so that's what we're going to focus on today. I'm going to start by showing off of this example because we already know what the answer should be. The answer should be 1, 2. And then we'll do a few other examples together so you get the hang of it. Okay, so starting off with this one. We've got, I'm going to use black for one equation, red for the other. I've got y equals negative 3x plus 5. And the second equation is y equals negative, 4x plus 6. Okay, and so substitution works the same way we've been substituting in the past, where we take one letter and we substitute some value or expression in for that letter. Now, it doesn't matter which one we start with. I'm going to go ahead and start with substituting the red function into the black function. And so to do that, I notice that this y, which is represented by this expression, is the same as this y. Okay, and so I'm going to substitute this whole thing, this whole expression here, into y. Okay, and so what's that going to look like? It is going to look a little weird, but we end up having a system of, an equation where negative 4x plus 6 equals negative 3x plus 5. Okay, so again, I just took this red expression here and I substituted in for the y in the black equation. Okay, and now I can take this and I can solve, which is something we've been practicing since the beginning of this school year. So to do that, I'm going to carefully, let's add 4x to both sides. And I'm doing that because I want our x's to be positive. Okay, and then I'm left with 6 on the left, x on the right. Of course, that's a 1x, but we can leave off the 1. And then I'm going to subtract 5 on both sides, and 1 equals x. Now, a lot of students stop here. They say, okay, great, I got x equals a number and I'm finished. But if you remember, our solutions to systems are always an ordered pair. Unless, of course, we have a situation where there's no solution or infinitely many solutions. So we have to have a pair. So x equals 1 here, okay? And if you notice, I still need a y value. There's no y value yet, and I might be wondering, well, how am I going to figure out what that y value is? And so to do that, I'm going to go ahead and take the x value that I just got, and I'm going to substitute it in for an x value in one of my equations. Now, the nice thing about systems is I can take either one of those equations and substitute that in. It's going to work for both because we've all agreed that the solution is the point that works for both. So again, I can pick whichever equation I want to pick. I might want that x in the black equation. I might want this x in the red equation. Again, doesn't matter. I'm going to go ahead and go with the black equation. I've got y equals negative 3. Now again, I'm going to substitute whatever x was and then add 5. In this case, x was 1. And I put those in parentheses to indicate that I'm about to multiply. So y equals negative 3 plus 5, and negative 3 plus 5 is 2. And so now I have my y value, which I can fill in here, and I have my solution. And we know we're correct because we've got the graph to the left, but we can also prove we're correct by substituting our solution into both of those equations. So let's see what that looks like, just to make sure we're all on the same page. So our solution was 1, 2, okay? And we need to check. So we are going to check okay, so let's start with the first one. Y equals negative 3x plus 5. So again, I'm taking some color here. I'll plug in x, and I'll plug in y. There's my y value. And I'm just substituting those things in, which in my experience, you guys have become very good at. So I'm plugging in 2 for y, 1 for x. And I just want to make sure that both sides are the same. If both sides are the same, that means it's true. That means we did a good job. So nothing's happening over here on the left. It's still just a 2. Negative 3 times 1 is negative 3 plus 5. Again, nothing's happening on the left, so that's just a 2. And negative 3 plus 5 is 2. And that is true. So we did a good job. Let's check with the second equation. Y equals negative 4x plus 6. Again, I'm going to substitute y, and I'm going to substitute x. So I've got 2 for y, 1 for x, and I'm simplifying. Nothing's happening to the 2. The negative 4 is being multiplied by 1, which is just negative 4. Again, nothing's happening to the 2, and negative 4 plus 6 is 2. So again, it's true. Okay, and this is how I know that 1, 2 is a solution to that system. Okay, so because we got true for both of them, 1, 2 is a solution to the system. Okay, so again, we have the solution already because we graphed it, but we wanted to see what would happen if we weren't able to graph and we had to solve it using algebra. And so we did that by substituting, discovered that the solution was in fact 1, 2. We substituted one equation into the other, and then finally a solution into one of those equations. And then below here, all we did was check. We wanted to check to make sure that it was indeed true. And if it is true for both, then that means it is a solution to the system. Okay? And that's why we're using substitution to solve systems of equations. We're substituting essentially 2 times in order to get to the 2 parts of our ordered pair. So let's try with another example. This example is coming out of your textbook. We're working out of chapter 5, section 1, so that's 5.1. And let's do that example together. Okay, so in case you're following along with your textbook, we are working out of section 5.1. There are other examples there if you'd like to read through those. I'm going to use some of these problems to do some examples with you. So let's look at number 14 first. I'm going to change number 14 around a little bit just so we can see other examples of how things can be substituted. So for this first one, I'm going to use red, and I'm going to write y plus x equals 4. Okay, so I've altered the example from your textbook a little bit just so that we can see a different format or a different way of substituting. Just looks a little different from what we did just now. And then the second one is y equals 2x minus 8. So again, I'm going to start by substituting one equation into the other. Okay, and so in order to do that, I'm going to go ahead and take this function, 2x minus 8, and I'm going to substitute that in for y, and the other function, that y is here. Okay, now notice it's not on the other side of the equal sign right now in that red function, and that's okay. We can still substitute 2x minus 8 into y. Okay, so just to rewrite that, y plus x equals 4. This is the equation that I'm going to use to substitute in my blue expression for y. Okay, and so that's going to end up looking like 2x minus 8. There's my blue expression, right? And then the rest of the red stays the same. Okay, don't forget that plus x. A lot of students forget that plus x, but it's still there. It hasn't gone anywhere. And now I've got to start combining like terms. We're just simplifying again. Same thing we've been doing for quite a while now. So 2x plus x, we all remember that there's a 1 in front of here. So 2x plus x, that becomes a 3x minus 8 equals 4. So again, I just combined like terms here, 2x and x. Okay. And then I'm going to add 8 to both sides. Again, we're trying to isolate the x. 3x equals 12. And now to get x alone, I've got to divide both sides by 3. And x equals 4. So again, and I would suggest this at the beginning of your problems, please make sure to make an ordered pair. Okay, so we don't forget that we are in fact looking for 2 parts when we solve these. Okay, so my x value is a 4, and of course x goes first and then y. So I'm going to put 4 here. Okay, and if I set this up this way, then I know that I still need another part. I still need the y part. So what I'm going to do now is what we did before. I'm going to take my value of x and I'm going to plug it in to one of the equations above. Again, it doesn't matter which equation we use. I'm going to go ahead and use the blue one since we haven't used it yet. Okay, so y equals 2x minus 8. And again, I am plugging in my 4 for x. So y equals 2 times 4. I'm using parentheses in order to show that I'm multiplying. Okay, y equals 2 times 4 is 8. And then 8 minus 8 is 0. Now 0 is an okay answer. A lot of students get to 0 and they say no solution. 0 is still a value. It just means that we're ending up on 4, 0. So on the coordinate plane, I'm going to be right on the x-axis. Okay, so that again, just to kind of confirm that 0 is okay as an answer, 4, 0, 1, 2, 3, 4 is right here. Okay, so that answer is okay. And it shows that our 2 lines would cross each other at this point. Okay, now to confirm that these are true, I can go ahead and do this again, where I substitute everything and prove that they're true. I'm going to do that quickly now just so we can see. Okay, so y is 0, so y plus 4 equals, y plus x equals 4. I'm going to substitute my values. Y is 0, x is 4, y 0, x is 4. Okay, and I'm just trying to make sure it's true, that it's the same on both sides, so that one's good. Okay, didn't make any mistakes there. Now over here, y equals 2x minus 8. X is yellow. Y is blue. And I can substitute those guys. Y is 0. X is 4. 0 equals 0, and that's true. Okay, so now I know that I did a good job. 4, 0 has to be my solution. I just proved it by showing both of them are true. This step is a good step to know because I will be asking if an ordered pair is a solution to the system, and this is a great way to check. Okay. So let's look at one more example together, just to continue to get the idea of how these systems are working. It is the situation where sometimes you will not have an equation that's already set up to substitute. So let me show you what I mean by that. For example, let's do number 20 from your textbook. So your textbook has number 20, and it's set up with both linear equations in standard form. So I've got 3y plus 4x equals 3, and x plus 3y equals negative 6. Okay, now none of these say x equals an expression or y equals an expression. Both of them are in standard form, and what that means is both x and y are on the left side or on one side together. So how can we set this up so that it's ready for us to substitute? Because right now it's not ready for us to substitute. So one way to do that is to isolate one of the variables. We have lots of options here. We have x's and y's in both equations, but I'm going to go ahead and try and isolate this x value right here. And so why am I choosing that x value? Well, the main reason is because it has no coefficient, so I won't have to divide later. Okay, so what do I mean by that? So if I subtract 3y from both sides, then I get x equals negative 3y minus 6. And I'm done there. I have it all isolated now. X is alone, and it equals some expression. If there had been a variable in the front, for example, a 3, I would have had to divide this side by 3 and this side by 3, and that would have been pretty troublesome. So instead of having to worry about that for now, I just decided to choose the variable that was already pretty much alone. I just had to subtract 3y from both sides. Okay, so now that x is alone, I'm going to go ahead and use blue again, and I'm going to substitute the blue expression into the red equation for x. So let's do that first. 3y plus 4x equals 3. And again, I'm substituting this expression into x here. So I've got 3y plus 4 in parentheses, negative 3y minus 6. Okay, now this one looks a little more complicated than usual, but we can handle these things because we've been doing them since the beginning of the school year. So I'm going to start by distributing. Let me stay color-coded here. Okay, so I'm distributing through the 4 through to the expression that I just plugged in. So 3y minus 12y, 4 times a negative 6 is minus 24 equals 3. And I'm going to continue to simplify. I've got combining like terms here. Negative 9y minus 24 equals 3. Add 24 to both sides. I'm going to move my work up here. Negative 9y equals 27. And when I divide both sides by negative 9, don't forget the negative, y equals negative 3. Okay, so up here I'm going to go ahead and put my solution. I know I've got an x and a y. And this time, my solution started off with a y, so I'm not going to put the negative 3 here. That wouldn't make any sense. That's the spot for x. It's reserved for x only. So I'm going to put my solution of y minus 3 equals minus 3 right here. Y equals negative 3. So now I'm going to continue. x equals negative 3y minus 6. And again, I could plug in this value into any equation I want, into the red one or the blue one. I chose the fixed blue one, the one that we rearranged, because now x equals some value. And so I can just simplify on one side, which will be nice. So I'm going to plug in negative 3. So negative 3 here. I'm going to plug it into y over here. Okay, so I've got x equals negative 3 times my value for y minus 6. X equals negative 3 times negative 3, that's 9. And x equals a positive 3. And I can place that into my solution. Okay, so I'm going to leave the check to you for this one. Those are 3 examples you can look to for your homework. The first one being with 2 equations where they're set up y equals. The second one, an equation where one variable is set up and the other is in standard form. And this last one where we had 2 standard forms and we had to set up a variable to be alone first before we can try and solve the system. Again, you can always check your answers by plugging them in or by graphing, since you do have access to different graphing tools now. But otherwise, that pretty much wraps it up about substitution. So if you have any other questions, please feel free to message me, contact me. You can get in contact with me through Schoology or Remind. For our next meeting, we will be talking about some special circumstances with substituting in systems. We already talked about those instances where we have no solution or infinitely many solutions, and it's going to be important to see examples of those as well. So that's for next time. Until then, good luck. Try these out with your homework. I will be posting homework number 8 in Alex. Do your best, continue to take care, and I hope to hear from you soon.